Quantum entanglement sounds like science fiction, but it's real. Imagine two tiny particles that are so closely linked. Whatever happens to one instantly affects the other, even if they're light years apart. That's entanglement. They're not sending messages between them, and they don't break the speed of light. Instead, the universe treats them as one system, no matter the distance. You could measure the spin or energy of one, and the other will match instantly. Even Einstein was baffled by it. He called it spooky action at a distance. But scientists have tested it in labs using photons and electrons, and it works every time. Entanglement is now a real part of quantum physics and the foundation for mind-blowing technologies like quantum computers and teleportation. It challenges everything we thought we knew about how space and distance work. True or false? Entanglement requires sending a signal between the particles. False, the connection is non-local and doesn't involve any message or signal traveling between particles. What happens when you measure the state of one entangled particle? The second particle's state is instantly determined. Fill in the blank. The idea that entangled particles act as one system is called quantum blank. Entanglement. Fill in the blank. Einstein called entanglement blank action at a distance. Spooky. Why is entanglement not considered faster than light communication? Because the results are random and can't send usable information. If two entangled particles are separated by 300,000 kilometers and one changes state, how long would it take for a signal traveling at the speed of light to reach the other? To find how long it would take light to travel between the particles, we divide 300,000 kilometers, converted to 3 times 10 to the 8th meters, by the speed of light, which is also 3 times 10 to the 8th meters per second. That gives us exactly 1 second. True or false? Entangled particles can affect each other instantly, no matter how far apart they are. True. Fill in the blank. Measuring one particle instantly affects the blank of its partner. State. Which experiment proved that entangled particles influence each other instantly? Bell's inequality test. Fill in the blank. The theory that explains entanglement without classical signals is called non-blank. Non-locality. True or false? Einstein was a strong supporter of quantum entanglement. False. He famously disliked the idea and called it spooky action at a distance. If a quantum signal appears to take 0 seconds between two entangled particles, but they're 700 kilometers apart, how far are they in meters? To express the distance between two entangled particles in meters, we multiply 700 kilometers by 1,000. That gives us 7 times 10 to the 5th meters, or 700,000 meters. Which technology could be powered by quantum entanglement in the future? Quantum teleportation. Fill in the blank. Entangled particles can be separated by blank of kilometers and still respond to each other. Thousands. If a particle on Earth reacts instantly to a change in its entangled partner located 3.6 million meters away, how fast would a signal have to travel to cover that distance in just 1 nanosecond? That's 1 billionth of a second. To find the speed needed for a signal to travel 3.6 million meters in 1 nanosecond, we divide the distance, 3.6 times 10 to the 6 meters, by 1 times 10 to the minus 9 seconds. The result is 3.6 times 10 to the 15th meters per second, far faster than the speed of light. How did you do? Tell us in the comments below. And thanks for watching BrainyKidz. We hope you had fun learning today. Don't forget to like, subscribe, and hit the bell so you never miss a new quiz. See you next time, Brainy Friends.